So this is tutorial question number 5. A cup weighing 5 Newton was filled with 1 liter of liquid X. They float in water as shown in Q1. Determine density of liquid X for the system to become neutral equilibrium. So neutral equilibrium means the value of Gm is equal to 0. Because according to the definition, if Gm greater than 0, it is stable. If Gm is less than 0, it is unstable. So means they still have one condition, which is the Gm is equal to 0. So Gm equal to 0 is called neutral equilibrium. So what is the meaning of neutral equilibrium? So it means that if Gm is greater than 0, means that it's capable to return to its original position. How it can return to original position? Because it could create moment. Again, when Gm is less than 0, means in negative value, so mean it's create moment, but that moment is actually not returned to the original position, but that moment will lead to another position. So it is unstable. So Gm equal to 0 means there are no moment acts on the object. So means that there are no, if you give slightly external force on that system will rotate. But after that, when you release the external force, that system will not return to the original position, and it is also not moved to another position. So this is the Gm equal to 0. So the simple example of Gm equal to 0 or neutral equilibrium is when you have something filled with water. For example, you have a cylinder like this. So and then your cylinder has liquid like this one. So means that you fill a liquid inside a cylinder and then you float it into in water like this one. So because actually it has a same liquid outside and inside the cylinder, when you give an external force into this cylinder, so this cylinder will change its position like this, but so it will remain the position like this for the time. So awak kena imagine bahawa neutral equilibrium ni adalah satu keadaan di mana sesuatu objek tidak menghasilkan moment untuk mengembalikan dirinya ke kedudukan asal dan juga tidak menghasilkan moment untuk menyebabkan ia berpusing ataupun mempunyai posisi yang lain. So dia akan stay di mana ia berlaku. Contoh yang paling mudah seperti yang saya katakan, contohnya antara real example adalah sampan yang bocor. So maknanya kalau awak ada sampan yang bocor, kalau awak sengitkan kapal, sengitkan sampan tersebut, so sampan tu akan kekal sengit. Itu sebab kalau kita lihat satu peristiwa di mana feri karam. Kalau awak ingat di Korea Selatan, saya rasa 2-3 tahun yang lepas, ada feri yang bocor actually. Feri itu kekal sengit untuk beberapa lama kerana ada kapal cuba tarik, ada tugboat cuba tarik feri tersebut, so dia menyebabkan feri itu sengit. Dan oleh kerana air telah masuk di dalam feri tersebut, feri itu akan kekal sengit untuk hari-hari yang akan datang, selagi ia tidak mengubah kedudukan feri tersebut. So itu yang dikatakan neutral equilibrium. So kita kembali kepada soalan kita di sini. So let's say we have something like this one. Again, we have a hollow cylinder, okay, and then was filled with 1 liter of liquid X. So and then they float in water as shown in the diagram. Determine the density of fluid X here. So and then you know that in this system we have two objects. One is the cylinder here and the other one is liquid X. So means that we need to calculate the center of gravity for the whole system. So and then in this calculation, so it is the submerged depth here is not given. So means that, so you need to calculate the submerged height here, submerged depth here, by using the idea of force of buoyancy and weight. So the solution will become like this. Okay. So we know that 1 liter means 0.001 meter cube. So and then the force equilibrium will become like this. Total weight is equal to force of buoyancy. And we know that the cup here is weight of 5 Newton. And then we need to calculate what is the weight of the liquid X here. So and then the total of this weight will overcome or the force of buoyancy here, which can be calculated using rho, g and volume. So that's why we are calculating this one, rho, g and volume. So and then the volume of X here is 0.001 meter cube, and the zero of water, the volume of water here is this one. Because in this question, the value of the depth here, the submerged depth here is not given. So means that it is okay for us because we are engineer. So we give label for this depth as H. So means that we could write the equation for the volume of the submerged area is equal to pi 0.06 square and H. So and then we substitute into this equation, so we could, this is the equation that we have here, but we still don't know the value of rho x here, and also we don't know the value of H, but it is okay because as an engineer, so we could create another equation and then we could do the simultaneous solution to find the value of rho x and the value of H. Then, from the question, we know that this system is stable equilibrium. So, stable equilibrium means Gm is equal to 0. So, previously, according to this axis, we could write Gm is Bm minus Bg. So, and then Bm here is equal to moment over volume. And Bg here can be calculated as OG minus OB. So I think you already know about this equation. So and then if Gm equal to 0, so means that Bm here is equal to Bg. So we start to calculate we have equation of Bm is equal to Bg. So and then the Bm here can be calculated by using this equation. So means I moment over volume. So and then Bg here can be written as OG minus OB. So and then we substitute all the value. So the OG here can be written as 0.14. So and then minus OB here is H over 2. So and then the I moment can be calculated like this one, and the volume can be calculated as this one. So and then if we write all of this, we could find this quadratic equation. So 0 is equal 8h square minus 2.24h plus 0.0144. So and then we could have two answers. One is 0.273 meter and another one is 6.58 times 10 to the power of minus 3 meter. So according to these two answers, both are positive. So means that both are can be chosen as answer, but normally we will take the largest one here because the small amount of this one, it is very small, means that it is not easy to determine its equilibrium. So we take H is 0.273 meter here. So and then another reason why we choose H is 0.273 meter, because we assume that the density of rho x here is greater compared to the density of water. So and then we substitute the value of H here in the equation 1. So we could get that the rho x is 2577 kilogram per meter cube. So and then we could calculate the rho GE here, means the specific weight, which is equal to 25,280 Newton per meter cube, and the specific gravity of this liquid is 2.577. So please bear in mind that specific gravity here did not have any units.